Today we're going to take a look at section 6.3 day 1, which is properties of trig functions. So this table up top should be familiar. This is what we've been using the last 2 days to find values for sine, cosine, secant, cosecant, tangent, and cotangent. So these ratios should look familiar. Okay, we also took a look at this before. Anytime I have cosine or sine, cosine always has to be followed by an angle measure. So the input is an angle. And again, that angle could be in either radians or degrees. And then the answer to cosine of 30 degrees or cosine of pi over 4 always has to be a ratio of the sides. So in this case, because we're talking about cosine specifically, it's the x value divided by the radius. All right, so today we're going to take a look at some angles that are not part of the unit circle. Okay, so we're going to go back to SOHCAHTOA or y over r, x over r, those same ideas to help us draw those pictures. All right, so in the first example, we are given the fact that sine is equal to negative 2 root 3 over 5. And we know that cosine is less than 0, or basically that cosine is negative. So the first thing we need to do is we need to figure out what quadrant to draw this triangle or this angle in. All right, so again, we know that sine is negative. So I know sine has to be positive in quadrants 1 and quadrants 2, because remember we have all students take classes. All means all are positive. This S for students means sine or its reciprocal cosecant are positive. T for take means tangent and cotangent are positive. And then the classes means cosine and secant are also positive. So I know if sine has to be negative, it can't be in quadrant 1 or quadrant 2. All right, so then we go to the fact that we know cosine is also negative. Well, here it says cosine's positive in quadrant 3, so it can't be quadrant 3. So I know my angle or my value for theta has to fall in quadrant 3. All right, so what we're going to do is we are going to draw a triangle. We are going to start here and we're going to draw straight out onto the circle. And we're going to go straight down to the x-axis. So this is going to be a right triangle. And my value for theta is going to be in the middle here, touching the x-axis. So we've got a nice right triangle. And one of the things we know about that angle is we know the value of sine. So we were given the value that sine is negative 2 root 3 over 5. All right, so what we need to do is we need to figure out what does that tell us about this triangle. Well, the first thing we can look at is we can look at the fact, going back to geometry, SOHCAHTOA. Okay, so we know that sine is equal to the opposite over the hypotenuse. Okay, or we can think about the fact that sine is also y over r. Either way, the opposite side here is your y value, and then the radius is your hypotenuse of the triangle. So again, using either of those, SOHCAHTOA or y over r, we can now label the triangle. All right, so I know the opposite side has to be 2 root 3. I know the hypotenuse has to be 5. Now, the problem with this negative sign being out in front is I don't know if the negative sign goes up here with the 2 or down here with the negative 5, but it can't go both places. So one of the things that we have to look at is the hypotenuse is really the radius of the circle. This number right here always has to be positive. Okay, so the hypotenuse of a circle, or the radius of a circle, always has to be positive, so your hypotenuse will always be positive. Also, I think it makes sense because we went down into quadrant 3, the y value has to be negative. So the only thing that we're missing, because eventually we're going to be asked to find cosine, tangent, secant, cotangent, and cosecant, we have to find that missing side. So we've got to find the adjacent side. All right, since it's a right triangle and we're looking for that missing side and we know 2 of the other sides, we can just use a quick Pythagorean theorem. Okay, so I'm just going to call this x, so we can go x squared plus negative 2 root 3 squared has to equal the hypotenuse squared, which is 5 squared. All right, so here I've got x squared plus. Now, got to be careful here. I need to take negative 2 root 3 and multiply it by negative 2 root 3. So I've got to multiply the 2's. So negative 2 times negative 2 is positive 4. Oops. So I've got x squared plus negative 2 and negative 2 is positive 4 times root 3 is root 9, which is also 3. And that has to equal 25. So this gives me x squared plus 12 equals 25. Move the 12 over, that gives me 13 for x squared. So I know x has to be either positive or negative root 13. Root 13 can't be broken down, so I can just leave it as root 13. So I'm going to erase that x right here. So I know that this piece has to be root 13, but I've got to decide if it's positive or negative. Because I'm going to the left, I know that that x value has to be negative. So you need to be very careful with your signs. If you're going to the left or if you're going down, that part of the triangle has to have a negative attached to it because we're talking about the location. So now we're going to go and basically do what we did with the unit circle. We're going to find cosine. Well, I know cosine is the x value over the r value. So the downside here is the r value is no longer 1 like it is on the unit circle. So we actually have to do x over r. So in this case, the x value is negative root 13 and my r value is 5. That doesn't need to be rationalized. It can't be reduced. I'm going to go ahead and rewrite that negative sign. So it should be negative root 13 over 5. Okay, tangent we know is y over x. So my y value is my opposite side, right? So this right here is my y value. So that's negative 2 root 3 over my x value, which is negative root 13. Okay, I know that 2 negatives gives me a positive, so this is going to turn to a positive. I also can't have a root in the bottom, so I've got to rationalize that by doing root 13 on top and bottom. So up top, I get 2 root 39, and on the bottom, root 13 times root 13 is root 169, or we know when you multiply a root by itself, it becomes positive. So your final answer here, because I cannot reduce a root in a number, and then 2 and 13 don't reduce either. So there is my final answer. Now, one of the things we can question ourselves is if we're in quadrant 3, all students take tangent should be positive, and we had a positive tangent value. Cosine shouldn't be positive, so I had a negative value up there. Now, the nice thing with secant, cotangent, and cosecant is we can go ahead and just take those previous values that we found. So for secant, we know it's the reciprocal of cosine, so it's just going to be r over x. So since this right here is x over r, I know I can just flip it. So I get 5 on top and root 13 on the bottom, and one of them has to be negative. It doesn't matter where you put the negative sign. So then we've got to rationalize that fraction. So I get negative 5 root 13 over 13 for my secant value. Cotangent is just tangent, the reciprocal, right? So I know that this guy has to be x over y. So I'm going to go back to the original that I wrote in green. I don't want to flip this because I already rationalized it. So I want to go to the smaller values here. So I know that the x value is negative root 13 and the y value is negative 2 root 3. Okay, so just like we did before, I know that 2 negatives when I divide gives me a positive. Now I've got a root 3 down in the bottom, so I've got to rationalize it by doing root 3 on top and bottom. So that gives me root 39 up top. Now be careful down on the bottom. That gives me 2 times, and then root 3 times root 3 is 3. So that's really just root 39 over 6. And there is my value for cotangent. All right, and then the last one is cosecant. Well, I know cosecant is the reciprocal of sine. So sine is y over r, so this has to be r over y. So my radius was 5, and my y value is negative 2 root 3. So again, we've got to rationalize here, so I've got to do root 3 on the top and root 3 on the bottom. So that gives me 5 root 3 up top. And also, I have a negative, so I'm going to go ahead and throw that negative out in front. And then this down here again is 2 times root 9, which is 2 times 3. So that gives me a 6. So again, the only thing that should be positive down here in quadrant 3 is tangent and cotangent. And if you look, those two signs are positive, and everything else we found was negative. All right, so let's do the same thing here. This time we're given some different information. I'm given that sine is positive root 10 over 10, so I know sine is positive. And I'm given cosine is 3 root 10 over 10, which is also positive. So again, we've got to look at our four quadrants. We've got to say all students take classes. So I know sine is positive, so it can't be down here. I also know cosine is positive, so it can't be in quadrant 2. Therefore, my triangle must be drawn in quadrant 1. That's the only place where sine and cosine are both positive. So I start at the origin, and I draw my radius out to the edge of the circle. I'm going to draw straight down to the x-axis. We always go down the x-axis. We never go to the y-axis. And I've got my right triangle. Okay, so just like we did on the last one, I can either use SOHCAHTOA or y over r. This is opposite over hypotenuse, or y over r. My theta always has to touch the origin. So my opposite side, or my y value, is root 10, and my hypotenuse, or my radius, is positive 10. Now, the nice thing here is I don't have to do Pythagorean theorem because of the fact that it gives us some more information. I know that cosine is the adjacent over the hypotenuse, or the x value over the r value. Well, because of the fact that the 10 is still the same as the radius for both parts, that means that x value has to be 3 root 10. And in this case, because we're going to the right, it's got to be positive, and we're going up, so that's got to be positive as well. All right, so I'm only asking you to find 2 different pieces here. So the first one is tangent, which we know is y over x. So my y value is root 10. My x value is 3 root 10. One of the properties with square roots is if I have a square root that's the same in the top and the denominator, I can reduce those. Remember, anytime we reduce everything from the top, we get a 1 up top. So this reduces to 1/3. So this one was kind of nice. I didn't have to rationalize. You could have rationalized, but obviously we want to reduce anything possible at the start. All right, last one is cosecant. Cosecant is the reciprocal of sine. Well, we know sine is y over r, so this has to be r over y. Well, one of the things is we knew that sine was root 10 over 10, so I know my y value is root 10, and I know my r value is 10. So I can look back at what I was given, or I can look back at my diagram. My radius is 10. My y value is root 10. Okay, this one does have a root in the bottom, so I am going to rationalize here. So I get root 10 over root 10, which gives me 10 root 10 over square root of 100, which is 10. And then last up is I can reduce here, so the 10s divide out to 1, so I end up with square root of 10 as my value for cosecant. Okay, could we have found all of them? Absolutely, but in this case, I only wanted to find 2. All right, next one, find secant and cotangent if tangent squared is equal to 1/3. And this is a little bit different. It says theta is in between pi and 3 pi over 2, right? So what this says is theta has to be smaller than 3 pi over 2. But it also says theta, right? The alligator's eating the theta, so theta has to be bigger than pi. Well, I know pi is here, and I know 3 pi over 2 is down here. So basically that tells me it has to be somewhere in between, or basically it tells me that that angle has to be in quadrant 3. So I know my theta is going to come from the origin. My radius is going to touch the side, and then it's going to come back down to the x-axis, and theta always has to touch that origin. So the downside here is we don't know just tangent. We were given tangent squared. So we need to do a little bit of work here. I've got to set tangent squared equal to 1/3, and I just want tangent. So that means I am going to have to square root both sides. So I get tangent of theta is equal to, don't forget when we square root both sides, you have to get plus or minus. And I don't know if you remember this, but one of the properties of square roots is that I can break up this square root into the square root of 1 over square root of 3. Right? We can't have square roots in the denominator. This is one big fraction that has a square root. So we have to break it up into these 2 parts. So I get root 1 over root 3. Now, some of you might be tempted to get rid of the root 1, but realistically, we've got to rationalize. So I'm just going to multiply top and bottom by root 3, which gives me root 3 on top and then positive 3 on the bottom. So I know that tangent is equal to plus or minus root 3 over 3. Now, technically, though, because my angle, my theta, is in quadrant 3, I know that tangent, right, because all students take my tangent value has to be positive. So in this situation, we can actually get rid of the negative sign because tangent has to be positive. So we know that, excuse me, tangent has to be y over x. So I know my y value here and my x value there. All right, so my opposite side, or my y value, has to be root 3, and my x value has to be positive 3. So one thing looks a little bit weird about this triangle here, because if I'm going to the left, I can't have a positive, and if I'm going down, I can't have a positive. So because of the fact that it goes to the left, I have to change this to negative 3 and negative root 3. Even though we said tangent has to be positive, if I take negative root 3 and I divide by negative 3, that does give me a positive. So again, anytime you go to the left or you go down, those values have to be negative. All right, so the downside here is we do not know the hypotenuse. So we need to find that with a little Pythagorean theorem. I'll do down here. So I get negative root 3 squared plus negative 3 squared has to be my hypotenuse squared. I'm just going to go h squared. You can do r squared too. It doesn't matter. So if I take negative root 3 times negative root 3, that's a positive root 9, or just positive 3. Here, negative 3 times negative 3 is positive 9, and that has to equal h squared. Oops, equal. So that gives me a 12 on the other side. So I've got 12 equals h squared. When I root both sides, I get square root of 12. Well, we all know that square root of 12 breaks down into 4 and 3. So h is either plus or minus 2 root 3. We already talked in the other example that the hypotenuse can never be negative. So I know that this just has to be positive 2 root 3. The hypotenuse is the radius of a circle. The radius is a distance. So that value always has to be positive. All right, so we only need to find two different pieces here. I need to find the secant. Secant is r over x, right? It's the reciprocal of cosine. So my radius is 2 root 3. My x value is negative 3. Well, the nice thing here is there's nothing to reduce. I don't personally like the negative in the bottom, so I'm going to rewrite it as negative 2 root 3 over 3. You absolutely could have left it like the top. And then tangent or cotangent is, x over y, because tangent's y over x, so it's just the reciprocal of there. And that gives me the x value, which is negative 3, over the y value, which is negative root 3. I know that two negatives gives me a positive. I also know that I have to rationalize this. So that gives me positive 3 root 3 over 3. Those 3's reduce, so I get positive root 3 for cotangent. So this is a little bit different because we're not using the unit circle, but we are going back to all of those things that we were using to find cosine and sine and tangent, r over x, x over y, y over x, etc. All right, some other properties that we need to talk about, which I think we've already talked about before, are the reciprocal properties. Okay, so we know that cosecant is the reciprocal of sine, or 1 over sine. Secant is the reciprocal of cosine, and then cotangent is the reciprocal of tangent. So we've talked about this a little bit with the unit circle. So if you look at your unit circle and we look at 30 degrees, the ordered pair at 30 degrees is root 3 over 2 comma a half. Well, we talked about the fact that the unit circle goes cosine comma sine. So if I'm looking for the sine value of 30 degrees, that's 1/2. Okay, now cosecant is the reciprocal of sine. Since sine is a fraction, I can just flip that fraction and make cosecant 2 over 1. Now, I talked about this in class the last couple days. Some of you might not like that, and you might want to do 1 over 1/2, which is 1 times 2 over 1, and we still get 2. Okay, so either way is okay, but because we're taking the reciprocal and we have a fraction, we can just go ahead and flip that fraction. Couple other really important properties are the quotient identities. We said that tangent is y over x, right? Well, we also said that the y value is sine and the x value is cosine. So really, tangent is just sine over cosine, or the y value, which represents sine, over the x value, which represents cosine. Okay, and cotangent's the reciprocal, so that's just x over y. And again, x represents cosine, y represents sine. So again, these are more properties that we will use quite often as we get further into trig. All right, so let's use those identities to simplify these problems right here. So notice that my angles are the same, and notice that we have cosine divided by sine. Well, we just said that cosine divided by sine is equal to cotangent. So since these angle measures are the same, I can just rewrite this as cotangent of pi over 3. Now, I'm also subtracting cotangent of pi over 3, and anything minus itself is just 0. All right, so I have a small problem here. I've got some negative angles. These two angles aren't the same, but let's see if we can make them the same. So yesterday we talked about coterminal angles. So I can always make angles coterminal by adding or subtracting 360. So negative 50, in my opinion, is too small, so we're going to add 360. So that gives me sine of 310 times cosecant of 670 is too big, so if we subtract 360, that also happens to give me 310. That is not a coincidence. I did it on purpose. All right, so now we've got to multiply sine and cosecant. Well, I know that sine stays sine of 310, but with the reciprocal properties, I know that cosecant is 1 over sine. So just like we did with the calculator, I can rewrite this as 1 over sine of 310. Well, the nice thing that happens here is I can reduce. Sine of 310 on the bottom reduces with sine of 310 on the top. This becomes a 1, this becomes a 1, so I just get 1 times 1, so my final answer is 1. So this is using those properties just to simplify and get exact values rather than plug it into our calculator. All right, so yesterday we talked about the unit circle, just like we did up above. You can add or subtract 360 to find a coterminal angle, or you can add or subtract 2 pi if it's in radians to find another coterminal angle that would have the same sine, cosine, secant, cosecant, tangent, and cotangent values. All right, so one of the things that we're going to look at is with tangent. How many degrees can we rotate for tangent to repeat? Okay, so tangent, if you look right here at root 3 over 2, comma 1/2, right? So we're looking at 30 degrees. If I do tangent, I have to do y over x. So that's 1/2 over root 3 over 2. Well, first of all, that fraction is positive. All right, so where else is tangent positive? Well, we said that tangent is positive in quadrant 3. So here, if I take negative 1/2 over negative root 3 over 2, I'm going to get the exact same value. I could divide it out if I want, but in this case, I just want to show we're going to get the same fraction because a negative divided by a negative is a positive. This would also work for cotangent. So cotangent and tangent repeat every half circle. So they actually repeat every 180 degrees, or not 2 pi this time. 180 degrees is the same as pi, so that's half a circle. All right, so if we take a look at this one, I've got sine over cosine. Well, we know that sine over cosine, if we go back up here, sine over cosine is tangent, but these angles have to be the same. So we've got a problem here because our angles are not the same. So if I add 360, that gives me sine of 340. Here, 700 is too big, so if I subtract 360, that gives me cosine of 340, which then gives me tangent of 340. Okay, if I go ahead and I subtract tangent of 340, the nice thing that happens is I end up getting 0. Okay, so your homework for today is on Math Excel. It's listed as homework 6.3 day 1. You are going to need to show some work, so please make sure you use a piece of paper or a blank Notability and show your work there. Have a great day.